exam programming. That's when you realize just on the funga tender much. Exam programming.
Okay, there we go. Yes. Yeah, the code works. And as you can see, there's a positive, strong positive relationship between departure delay and arrival delay.
Yeah. So
one would expect.
Yeah. So you can either do a joint plot, or you can also do.
Anyone with questions on this?
So you can also do a scatter plot or edge plot. So Luxon has done a range, so don't copy and paste Luxon's code. Don, I can't see your screen. Oh, what happened to Don? Python.
Hi, Doc.
Yeah. Just to find out from the rest of your class, are you guys okay so far? Because you guys are awfully too quiet. We don't. Maybe silence means you guys are. This is too easy for you, and you should just keep it.
Doc.
Yes.
Doc.
Yes.
Unfortunately, some of us don't have that much of coding background, so I think most of some of these things are quite new, and we're really trying to pace up so that at least we can understand some of the way these things work. So I think at times, if you're here so quiet, you'll be just trying to grasp some of these new things that you are seeing today. we're doing our best to try and catch up. But that's for me and a few other guys that I've talked to. But I don't know the other guys if they're a different position. So I hope you'll be with us so that at least we scale up.
Okay,
I think actually that's the position of most of the guys because we only have a few who have got a coding background. The rest are coming from commercials and social sciences.
Yes, Chinash. Python, are you still having challenges with recording?
Well, it's fine. We are recording. We started yesterday. We missed the first one.
Okay. All right. That's fine. So if you're recording and then you can then share.
Yes, the one for yesterday was shared to the whole group.
Hi, Doc.
Yes, Erickson.
Yeah, magetsi kuno kwaenda saka mungoziva PC yaDon.
Oh, yakafa battery. Yakafa zesa futhi.
Yeah, yakafa battery. So yeah, so I can take over. Tongopedzisa basa rapacho then.
Okay, all right.
Yeah.
Okay, please continue, Eric.
And which part of screen are you seeing from my end?
Yeah, we can see. So I think you're supposed to run code Yalaxon, the RH plot.
Okay, from the chat, right?
Yeah, from the chat you copy and paste.
Okay.
Why is Google Colab taking so long to run a simple function? It just doesn't make sense.
I think when magetsi kune kuaffecta futhi network yacho here. So maybe it's so there we go.
Yeah, okay, guys. So are there any questions on what we've done so far? So is everyone happy with with what we've done so far?
Well, I can say we yes, we appreciate what's coming up, and what then is left for us is maybe that to understand really how we can then be able to do it on our own and play around with these tools that you are giving to us. So I think, given the time, I think most of us will scale up and see how we can best understand some of this way, the process that we are seeing on the screen.
Yeah. Okay. All right. What I have done is I've also it's I think at this stage it's not important to look at the things like linear regression and so on. Yeah, not at this stage. Um, um, but so we'll first do um, machine learning, and then we'll then talk about linear regression and so on. So what I've done is, if you go to your Google Classroom, I uploaded a Jupyter notebook called Working with Numpy. So if you have a look at your Google Classroom, there's a notebook um, called Working with Numpy. Yeah. So can you please download the notebook and just let me know when you're done. And then we can just do NumPy very quickly. It won't take more than 30 minutes. Hello, can you see my screen?
Yes, we can see it.
You've managed to download the notebook, yes?
Yes, sure.
Yeah. So what we're going to quickly do is do Numpy. So Numpy, as we said, stands for numerical Python, right? So Numpy allows you to do numerical operations, and you'll see that everything in Numpy is defined as an array or a matrix. So the first example is just to show that I can create a matrix, right, with a 2 by 3 matrix called X with zeros 1 0 4 3 3 1, and then Y with 2 5 1 1 3 2. So uh, so we can then, if you want, so what NumPy allows you to do, for example, if you want to multiply the two matrices, or if you want to do the dot product, for example, so you can say x dot y, and then you should then get, I need to run it, and then you will get this as the answer. So then that will give you. So this is equivalent to. Let me just show you here, which makes it easier. Okay. Yeah, so can you see my screen?
Yes.
So in this instance, right, can you see them side by side? So basically, what Numpy allows you to do, it allows you to define matrices and operations on matrices. So one thing you'll notice about Pandas is built on top of a Numpy, and everything in Pandas, if you recall, is it's almost like it's a multi-term for especially data frames. Data frames are defined rows and columns. So you can think of a data frame as actually a matrix of data. So basically, this is what this operation will do. So it will take this x and multiply it by dot y. So which is simply this column multiplied by this row, and then you add, and then this column multiplied by this row, and then you add, and then you should then get this as the answer. So 2 multiplied by 1 multiply plus 0 times 1 plus 3 times 4 gives you 12 plus 2, which is 14, which is this 14 you're getting here. Then 5 times 1 plus 5 times 0 plus 2 times 4, which is 8 plus 5, which is 13, which is the 13 that you're getting here. Then 2 by 3, 1 by 3, 3 by 1, which is the 12 you're getting here. And then 5 times 3 plus 1 times 3 plus 2 times 1, which is the 20 that you're getting here. Right. So if I come, you can see my screen, right?
Yes.
So if I come here and say x dot, then if I do a tab, right? So if I do a tab, it will show me all the different matrix operations that I can do. I can do conjugate, I can do copy, I can do so on, right? So all of these operations you should be able to do on. I can then do transpose, right? T is for transpose. So if you recall, matrices, you did matrices in right. So if I say X transpose, can you see it is to transpose the it was a 3 by 2 to a 2 by 3, right? Yes. Right. Yeah. So it allows you to do numerical computations on data. So let's look at so one thing you must note that let's look at the basics of NumPy. So let's define a NumPy array or matrix which has got 1, 2, 3, 4, 5, 6. So if we want to find out what type of data structure that we've created, we can say type X. So then this will give us that we've created an ND array, right? So we've created a class type of ND array, right? Which is a numerical data array. right? Is that clear? Right. So if we wanted to find the dimensions of the structure, we say our template is shape in terms of the shape. So this is a 2, right? That's correct. Yes, this is a 2 by 3. Yes, this is a 2 by 3 matrix, and we want to find out the size. So the size is 6. By size, we mean the number of elements that it contains. So 1, 2, 3, 4, 5, 6. Yes. Is that clear? So if you wanted to find out the size, you can also multiply the number of rows and columns. So in this case, you can say 2 by 3. It will also give you 6. Right? And if we want to find the dimension of the array, we say n dim. So n dim, it means it's 2, since it's a 2 by 3 matrix, right? The number of dimensions is defined by the size of the rows. Yes. So this is row 1 and row 2. So we've got 2 rows. So therefore, our dimension of our array is 2. Is this clear? Come on, guys. Is this clear?
So good, Doc.
It's clear.
Yes, it's clear, sir.
Yeah. So if you wanted to print the data type, the data type simply means what values are stored within X, and then it will tell us it's an integer 32, right? And then if you wanted to find out how many bytes in terms of memory that it consumes, then it will tell us that it consumes 24 bytes. Right? Right? And one thing also you can do is, since we've got an int 32, what we can do with Numpy array is we can also change the data type, right, from integer to float. Right? So we can then say, right, so this will then give us a point to say that now it's not a float, and then you can see the number of bytes, right? If we print the number of bytes, right, that it consumed, you'll see now it's much bigger, it's double than what is consumed by integers and int 32. Right. So what Numpy also allows you to do is you can also define a complex. Remember, in mathematics, you could do complex numbers, right? A complex number, right? You guys remember complex numbers? So complex number is a number that has got an arbitrary a number like I, which is considered to be a complex number where I squared is equal to -1, if you recall. So in this case, we've defined our array, and then we can then change the data type to define the data type to be a complex, right? And then we can also define types like unsigned integer 32, right? And then you'll see that this then changes to an unsigned integer. Right? And then the good thing about Numpy array is it allows you to, for example, right, so here we've defined a float, and if we wanted to change it to integer, we can then say s-type int, right? So S-type integer. So we're now converting a float to integer. So you can also create a Numpy array of random values. So in this instance, we created a Numpy array which has a Numpy array which has got 1, 2, 3, 4, 5, which is got which is 100 so it will generate 100,000 of values. So we can actually see if we can see the structure. It's too big. So if you want to, for example, so here you see it's showing you. So therefore, if you wanted then to find out the actual shape, you can then say what shape, then you see it's 100,000 by 100. So you can do this to generate, if you wanted to generate random data for testing, for example, you can actually use some of these functions to do that. So let's look at, for example, you can convert a list into an array, right? So you do that by defining a list, and then you then put that list into a Numpy array and say that you want that list as an array. And the other operation that you can do on Numpy is you can, if I say my array plus 2, it would add 2 to every element within the array. So here it's added 2. You can see it's now 4, 16, 8. And if I say minus 1, it will subtract minus 1 from every single element within the array. If I say times 2, it will multiply every element by 2. If I say divided by 2, it will divide every single element by 2. So if I say this, so basically what this will do is if I say NP 04, what this does is let me just create something here, but it generates an array with 4 zeros. Then what I've done is I've added 3, right? And it's added to every 0 element within the array is added 3, right? And then what I can then do is I can then subtract. I can also subtract 2 arrays from each other. So if you remember my array from the second array, which is this one, so then it should then give. So then it should be the last. My array, yeah, right? My array, where's my array? So my array is, you print it off here so that you remember what it is. So if we say this minus 10, so it's then 2 minus 3, which is minus 1, 14 minus 3, which is 11, 6 minus 3, which is 3, and then 8 minus 3, which is 5. We can also divide, say, second array minus divided by array. So what it will do is it will say second array is this one. So it will say 2 divided by 3, 14 divided by 3, 6 divided by 3, and 8 divided by 3. So which then gives you this answer. So it takes every element, right, from then each array and divides it to the corresponding position of the element in the other array. So NP1s will generate, so moving on to the next line, so NP1s will generate an array of ones only. Let me, array with 4 ones. Right, then if I add 3 to those, it will all give me a 4, 4, 4, right? Then we can then say similar operation, my array minus second array, which is 4, 4, 4 minus 3, 3 should be then should be that. Then we can also do the division. If we consider, if you remember matrices, so if we say NP dot ones 4, what this will do is it will give us, so the identity of a thing is what is, so if we create sorry, what am I doing? So for example, if we say NP identity, so we were creating a 4 by 4 identity matrix. So an identity matrix is a matrix which has got a diagonal of all ones, right? So you can also create things like identity matrices. And then if we then add 3, what it will do is to add 3 to every element within the array. Moving on to the next one. So I'm going very quickly because this should be easy and simple, right? So for example, if we then say second array divided by my array, it will then divide every element corresponding to each other element. And then we all know what a range does, yes? So if we say NP a range, so what this does is it will start off with 3. The upper bound value is 7, and then it will increment by 0.5. So what it will then do is to then say 3 plus 0.5, which is then 3.5, plus 3.5, so the next one will be 4, and so on and so on. And then it will end up at 6.5 because 7 is the upper bound value. So you can also use something like this to generate a random data. Then there is a linspace, which this function, which means linearly spaced. So linearly spaced will simply create an array starting with 1.2, and then this is the, and it ends at 40.5, and then it will generate 20 numbers between 1.2 and 40.5. So it will linear, that are linearly spaced, right? So it will generate 20 numbers between 1.2 and 40.5, which are linearly spaced. So if I wanted to create some regression a function, for example, I could use this to actually create a perfect linear plot, because the values between 1.2 and 40.5 are linearly spaced. So therefore, if I then say my y is equal, it starts at 1 to 20, and if I plot that, that should give me a perfect linear plot. And then geom space stands for geometric space. So if I have 1 and 6 to 5, and then I have number is equal to 5, what that will do is it means it will start off at 1 and end at 6 to 5. So what that simply means, the first number will be 5, and then the second one will be so it was, the number is 5. So what it would do, it will say 5 to the power 0, 5 to the power 1, 5 to the power 2, 5 to the power 3, and then 5 to the power 4 to give us 6.25 as the outcome value. Yeah, you get this one, yes?
Yes, Doctor.
Yes, sir.
And then a log space, what log space does is it will take I'll have to show this on my calculator. What does my calculator have? Log space scientific log. Log. Right, can you see that? So if I say 1,000, so basically what is this? This is simply doing is, if I say log of 1,000, it will give me 3, right? Right. So I'm doing 5 numbers starting from 3 up to spaced equally. So the next, so I've just done, if you can see here, log 1,000 will give me 3, right? So the next one will be uh, 1778.279. Right. Can you see what's happening here? So I'm incrementing, right? I'm starting off at 3. I'm going to end at 4, right? My upper bound value. But I need to create 5 numbers between 3 and 4, right? So basically, what I've done. This is equivalent to saying now. Since this is to log the base 10, right? So this is equivalent to saying 10. Let me cancel. Let me. So this is equivalent to saying 10 to the. So right. this is equivalent to saying 10 to the power 3, right? Then the next value after that, because we want numbers between 3 and 4, which are spaced equally. So the next number will be 3.25. Then we then say to the power of that, which will give us the 1.78, this one. So the next number after that, obviously, is 3.5, right? 3.5, then say to the power of that, then it will give us this one, 6.2, and so on and so on until we get to the last number, which is which is 10 to the power 4, which is 10,000. Are we to, is this clear, guys?
Yeah, we're following, Doc.
Okay. So what this will do, MP log space, so we're taking log 10. So what this will do is it will produce numbers between log 10.3 and log 10.4. It will produce 5 numbers. So this is 1, 2, 3, 4, 5 that are equally spaced. Then you can also, yeah. So what you can also do, you can also, if you want to check that two arrays, if you want to compare them to find out if they're equal, right? You can then you use double equal. So if x is equal to 1, 2, 3, 4, and then y is equal to 1, 3, 4, 4. If I say x equal y, then it should give me for each element it should then say true. For this is false, and that is false, and that is true. So it will compare every element within the array with the its corresponding element within the array, right? Or else I can say NP array underscore equal. Then I can say x is x equal to y. Then the answer is actually false. So with this, it will just give me, if every element is not equal, it will then give me an answer which is false. Right. So if I say x less than y, what that will do is it will compare, say, is 1 less than 1, is 2 less than 3, is 3 less than 4, is 4 less than 4, right? Then it will, obviously this one is false, this one is true, that one is true, and that one is false. Right, and you can also, for those, so some of you, this might not make sense because you haven't done computing science, but it will make more sense when we're doing deep learning. You can also do logical operations. So we've defined this as type Boolean. So Boolean simply means it's either 0 or 1. So this is 0, 1, 0, 0. That's x, and our y is 1, 1, 0, 1. So our logic or operator, if we say x, y, so we're saying 0, 0 or 1 will give us 1, 1 or 1 will give us 1, 0 or 0 will give us 0, 0 or 1 will give us 1. So this should give us 1, 1, 0, 1. Right, so therefore it should give us true, true, false, true, yeah? 1, 1, 0, 1, true, true, false, true. So then if we say AND operation, says 0 and 1 should give us a false, 1 and 1 should give us true, 0 and 0 should give us true, and 0 and 1 should give us false. So it should be false, true, true, false. False, true, false, true. Oh, sorry. So this is false, 1 and 1 is, that's true. Yeah, this is false, and that is false. 0, 0 is false. Yeah, that's correct. Yeah. So if we've got an array, for example, with 12, 16, 57, and 11. And if we say x less than 13 and x greater than 50, what that will do if we apply an OR logical OR operation, what it will do is it will take x and put it there, right? So it's 12 less than 13, right? And then 12 greater than 50, right? The OR operation of that. So that is true. And then we take 16. Is 13 greater than 16? And then is 16 greater than 50? So that is false. And then we then move on to 57. Then that becomes true, and then that becomes true, right? Or and then if we have an array, 1, 2, 3, 4, and if we wanted the exponential of each value, we can say NP exponential of x. What that would do, it will give us the exponential of 1, of 2, 3, and 4, which are these values. Then NP log x, it will give us the logarithmic value of, or the ln value of 1, 2, 3, 4. So which is 0, 0.69, and so on. And if you wanted the sine value of x, we just say NP sine x. Yeah. And then if you wanted to create values from 0 up to 9, we can say NP a range up to 9. And then what this will do is it will create values from 0 to 8. And remember, it starts counting at 0, right? So therefore, to generate from 0 to 8. So what we can also do is, if we want to change the shape of an array, we can say reshape. So what this will do is it will take this list, right, this array, and then it will change it to a 3 by 3 matrix from an array with 9, a 1D array with 9 to a 3 by 3. So what this will then do is then it will say 0, 1, 2, 3, 4, 5, 6, 7, 8, right? Then it becomes a 3 by 3 a matrix. So reshape will reshape an existing array into the new dimensions that you would have that you specify here, right? So that's what reshape does, right? And then we transpose. Then it will transpose this array. So this is 1, 1. This is 1, 2, and so on and so on. So this comes here, and this remains there, and so on. Right? If you remember what transpose does, right? Then we get the transpose of this. Yeah, is this clear, guys? So,
Yep. Sorry, Doc.
yes.
If we can go back to the example you gave us on line 56, is it possible to come up with a reshape of another, not 3 by 3, maybe 4 by 4?
You can't do 4 by 4, can you? Because you don't have. Let's see.
Not necessarily the number. The 9 and the 3 and 3 are squares officially, isn't it?
Yeah. So
you can only work if the 9 is the square of the reshape.
see, it will not. It will not work. Why?
Okay. All right.
It will not work, right? Can you see why? Right. But if I had said, can you see? Can you see this works? Yes.
Sure. All right. Yeah. That confirms my. All right. Thank you so much.
Yeah. Can you see this one, which confirms, right? And then we can transpose that. Yeah. So what we can do is, if we want to sum all the elements within the array, we can say np sum x, and then it will give us that. And then np, what is the minimum of x is 0, right? Within the array. What is the maximum is 8. Yeah. So because our x starts, where is it? This is our x, goes from 0 to 8. So the minimum is 0, the maximum is 8. So if I say, what's the minimum? If I say sum x, it will sum every element from 0 up to 8. So it will say 0 plus 1 plus 2 plus 3, which gives us 36. And if I say, what's the minimum? It is 0. What's the maximum? Is 8. And then if I say a minimum x is equal to 0. So what that does is I've got my x, right, which is, so that you get this. I've got my x, which is 0, 1, 2, 3, 4, 5, 6, 7, 8. Right? Oh yeah, sorry. This is my x. What am I saying? This is now my x, isn't it? This is my x. So this is my x. So if I say a minimum x and x is equal to 0, what that simply means by x is equal to 0, it means we're doing, we're now doing it column-wise, right? So if I take, so to explain this, let me take a screenshot. Right, so you can see, right, this is my x, isn't it, right? So if I say x is equal to 0, what that simply means is I'm doing it column-wise, right? So I say, in this column, what is the minimum value, right? Is what? Right? In this column, what is the minimum value? In this column, what is the minimum? Let me change color. In this one, what is the minimum? What is the minimum value, right? So in this instance, we then get, if I write here, we then get the minimum for this one is 0, right? And then for this one is 1, yes? And then for this one is 2. Yeah? For these columns, yes?
Yes.
Yeah, so x is equal to 0 means column-wise. Are we together? Yes?
Yes,
So this is the answer, yeah? So if I say x is equal to 0, it means what? What does it mean?
column-wise.
it means column wise, right? So if I say axis is equal to 1, it means row wise. So if I come back here, what that means is if I now use this, let me use green. So if I say column wise, so if I say what is the function that we're trying to do now? So now we're saying a minimum and then x is equal to 1. What is the minimum value for each row? That's what it's simply saying. Right, so for this one, the minimum value is what here, it's what is 0, right? Then for this one, it's what? The minimum is what? Is 3, isn't it?
That's it.
Yeah, so it's, so for this one is 3. It's 3. This one was 0. And then for this one, it's what? It's 6, isn't it? So now we're doing it, so x is equal to 1 means row wise. X is equal to 0 means column wise. So we can then actually then check the answer here, and then we should get 036, which is what we are expecting here, isn't it? 036. Yeah? Is that making sense? The difference between x is equal to 0 and x is equal to 1.
Yes.
Yeah. Yeah? Yeah, and then if we say in the percentile, the 80th percentile of x will give us a 6.4. And then if we say NP array 1 minus 21 minus 3, if we say NP arg max x, what that will do is it gives us 2. So if I take this and also show you. Yeah, so NP argmax, what it does, it looks for the maximum index value of x. So if you recall the index locations here, this is index location 0. Yeah, this is index location 1. This is index location 2, and that's index location 3. Size. Yeah. So these are the index location. Yes, this is 0. For this element 1 is 0. For minus 21 is 1. For 3 is 2. And for minus 3 is 3. Yes. So if I say NP arg max x, I'm saying give me the index of the element with the maximum value. So the element with the maximum value is what?
That's 3.
Right? It's this one, isn't it? Yes? The maximum value is what? Is 3, yes? We're in agreement here. Yeah, and it's what index position is it?
2.
Yeah, so NP argmax returns the index position of the maximum value, which is what?
2.
Yeah, there we go. Yeah, is that clear? So in this instance, it gives us what? Are we clear, guys?
Yes.
Yeah, and then NP argmin will give us the index position of the minimum value, and in this case, it's what? The minimum value is minus 21, isn't it? So that's 0, 1. So it should give us what?
1.
Come on, guys. 1, yeah?
Yes.
Yeah, there you go. It gives us 1. All right. That's X. So NP min X, what that will do is it will add all of these values and give us the mean of 2 plus 3 plus 4. Sorry, 2 plus 3 plus 5 plus 20 plus 12 plus 4. The mean of that, right? So NP min X will add all of the elements and divide them by 6. Yeah? Yeah. So if I say NP, yeah. So if I say NP mean X is equal to 0, what do we expect this to do? I showed you what X is equal to 0 does. What will it do?
It will consider the columns.
Yeah, so what do you expect it to do? You will expect it to say what?
Calculate the mean for all the columns.
Yeah. So that's correct. So we expect it to say 20 plus 2 divided by what? By 2, since there are 2 elements, right? Which is 22 divided by 2 is what? Is 11, isn't it? And then 3 by 12, 3 plus 12 is 15, divided by 2 is 7.5. 5 plus 4 divided by 2 is what? Is 4.5, right? And then X is equal to 1. Well, what do we expect? Yeah, so we're expecting it to say 2 plus 3 plus 5 divided by 3, which is 8 plus 2, right? 8 plus 2 is 10. 10 divided by 3, right? Will give us, and then 20 plus 12 plus 4 divided by 3, right? So this will give us 3.33, and this will give us 12, yeah? And then NP median X will give us the median value of X, right? And then NP will give us the standard deviation of X. So it will take it will give us the standard deviation of all of these of 2, 3, 5, 20, 12, and 4. Yeah. This is clear, yes?
Yes.
Yes, quite okay.
Yes.
So if we say NP ones, if we now let's look at working with multidimensional arrays. So if we say NP ones for it will give us a 4x4 matrix with ones. Then if we multiply that, it should then give us all right, let's see what 1, 2, 3, 4. All right, and then this. Okay, I think one thing you need to note is if we so let's look at this so that you guys understand, you don't get confused. So if I say if I do this, right, if I say MP once, what this will do is it will give me a 4x4 matrix with ones. Are we together? Yeah.
Yes.
Are we together?
Yes.
So if I say C times C, this is a multiplication, right? What this will do is it will say, it will take this and say 1 times 1, right? So it will try and multiply each element with each other by 1. So this is what this operation actually means. But if we want to do the normal matrix multiplication, this is when we then say dot. They need to then give us the correct expected answer. Are we clear? So that we don't confuse the star multiplication, right? And the dot, which actually means proper multiplication. Yeah?
Mm-hmm.
So let's say we've got, so let me remove this and make it easier to understand. So if we got 0 to 15 and we do that into, and we reshape that to a 3 by 5 matrix, and then we shape that to a 2 by 5. Right, so we get our y as this, and then we get our x as this. Yeah, this is clear, yes, for this operation.
Mm-hmm.
Yeah.
Fine.
Right. So what VStack, the operation VStack does is it will take y and stack y onto x vertically, right? It will create a new array and stack y onto x vertically, right? So we then expect this, right, to be stacked at the bottom of y. Yeah, are you getting it, right? That's what VStack stands for, vertical stack. So, right, so we're taking this and creating a one array where we are staking where we are staking x at the bottom of y. Is this clear? Come on, guys. Is this clear?
Yes, it's fine.
Yeah. So we're taking this, right, and then we're then staking this at the bottom. That's a vertical. That's a vertical stack. Then you can also have a horizontal stack, right? So in this instance, let me let's find out what the value of y then x. So in this instance, if we reshape to 5, 3, it will give us this, right? For y, and then for x, it will give us this. So therefore, if we then do a horizontal stack, which what this H stands for, it will take this, right, and append it to here, right, to give us a new array, which is now this, right? So what it simply has done is taken this data and appended it to here. So this is what horizontal stacking does. So what that simply means is, if you want to, we'll do this later when we're doing machine learning. If I want to stack my data, right? I can stack my data. If I've got two data sets, if I want to merge them, I can either merge them vertically or horizontally. Yeah.
Mm-hmm.
Yeah. Is that clear?
Yes.
Yes.
Yeah, and all of these other things, we've done them. I will not bother you with these. You did this with in pandas. I will not bother you with this. Let's do some slicing and dicing, right? Because that is also important. So we just revise. So if we've got an array called Zimbabwe, Malawi, Zambia, and Botswana, right? And if we say x2, we want, so this is 0, 1, 2. So it should give us what? What answer will this give us?
Zambia.
Yeah, it should give us Zambia. Right? If we've got so now this is now different, right? This is a list, yes, and this is now a tuple, because we've got brackets here. So if we say x2, it should give us so this 0, 1, 2, it will give us Malawi. Right? So let's say if we create an array with from 0 to 9, right? So this should give us 0 to 9, right? So x5 should be 0, 1, 2, 3, 4, 5, right? It should give us that. It will give us that. Then what will this give us?
It will give us 8.
It will give us 8. Yeah, that's correct, right? So what will -1 give us?
-1 will be 9.
So -1 will give us what?
9.
It will give us 9.
9.
Yeah. That's correct. And x to 8. So we're now slicing to say, what will this give us? I'm sure you did a bit of slicing and dicing with Don. So what this is saying, select from, yeah, so this is 0, 1, 2, yeah? Yes? Guys, so this is 0, 1, 2. So in terms of the indexing, this is 0, 1, 2, yes? So this is the second element, right? Yeah, and then this is the, so this is 0, 1, 2, 3, 4, 5, 6, 7, right? And this is 8. So what this means is select from the second element, and the upper bound is 8, right? So therefore it will return from 2 to 7. Is this clear? Because 8 is the upper bound value, so so it will return up to 7. So this is yeah, it will return up to 7. Yeah, this is clear, yes?
Yes, sir.
And what this does is, it will, since we haven't specified anything, right, it will return all the elements. Yeah, is this clear?
Yes, Doc.
Yeah, so it will start from, this is equivalent to say, start from 0 and end at the highest upper bound value, right? Which is 9. So it will do 0 to 9. So if you don't specify anything, it will take from the minimum to the max. Yeah? So what this one will do is, this one will start off at, so what this will do is consider this list, right, 2 to 8, right? It will give us 2, 3, 4, 5, 6, and 7, right? And what this is it becomes like a step function. So what this will do is give me every second element, right? So this is skip every give me so what this is it's a step. So give me every 2 steps. So this is the first. So this is one. So this is the second one, isn't it? Right from here, this is the second one, isn't it? It's 4, and then from this one, the second one is this one, yeah. So therefore, it then stops. Do you get it? Yeah.
Yes.
This is the 2 mean is it's like a step function to say, give me an array from, return the values from 2 to 8, where 8 is the upper bound, which is this 2, 3, 4, 5, 6, 7. But then this is a step function, simply meaning that return the values every 2 steps, right? This is 1, 2, 1, 2, right? Which gives us 2, 4, and 6. Yes? That's clear, yes?
Yes.
Yes, it's quite clear.
Yeah. Yeah. So if you learn slicing and dicing, you see when we start machine learning that this is quite critical and important. Yeah. So let me create an X where it becomes that. So I've got 0, 1, 2, 3, 4, 5. So if I say X 1, 3, what that will give us is 4, 5, 6, 4, 5, 6, 7, 8, 9, 10, 11. Right? Can you see I've selected yeah, can anyone explain this? Right? Can you see this is the law? This is we're starting at the first. We're starting on the first row, right? Yeah. So this is row 0. This is row 1. This is row. Are we clear on that one? This is row 0. Yeah.
Yes.
Come on, guys. In terms of indexation, this is row 0.
Yes.
This is row 1. This is row 2, and this is row 3. Right? So what we're simply doing is we're saying start off with the first row and the upper bound is the third row. So what that simply means, it will return row 1 and 2, which is this one and this one. Is this clear?
Yes. Yes.
Yeah?
Mm-hmm.
And then remember this. Yeah. So let's explain what this means. right? So what this simply means, remember, if we specify this, it means select all rows, right? Yeah. So this means rows and columns. So what is this simply saying is select all the of all the columns, right? And then the commas simply saying I want you to start selecting from the first column, and the upper bound is the what? Is the third column. Is that clear?
Yeah.
Yeah, is this clear? Yeah.
Yes.
Doc, how do we differentiate then that now it's referring to columns and here it's referring to rows?
Can you see here? There's no comma.
Okay.
Huh? So column wise, this is 0, 1, 2, 3. Yes.
Yes.
Yeah. Yeah. So what I've simply done is I'm slicing my data, isn't it? So to make you understand, to make it easier to understand, let's do this. So remember we said X. What does this do? It returns all what?
Everything.
Everything, right?
Everything, yes.
Yeah. So and then if I what does this do? Right. So
that is condition on the column.
yeah, right. Yeah. So now I'm not conditioning on now. What this means, I'm not conditioning on the column, right? But in this instance, I've said return all columns, isn't it? Because I haven't specified any condition, isn't it? Yeah. So if I do this, then if I put a 1, what does this do?
That one, first column. Column 1.
Column 1, isn't it? It's return 1, 5, 9, 13. Can you see? Yeah. Yes.
Yes.
Is this clear, guys?
Yes.
Yeah, very clear.
Now it's much clearer, isn't it? Yeah. So what this is simply doing is saying take column 1 and 2 because my upper bound is 3. So therefore to return 1, 5, 9, 13, 2, 6, 10, and 14. Yeah.
So sorry, Doc. Colleagues, can we mute our mics if you are not speaking so that at least we get a good sound projection on the recording? Okay, thank you, Doc.
Yeah, okay. Guys, is this clear what this is doing?
Yes, Doc.
Yeah? So this is returning a column. Yeah? Yeah. So now you understand what this means, yes? This is 3 is the upper bound value, right? So it will return the first, so it will return index column number 1 and index column number 2, which is this, which are these two. Yeah?
True.
And then what we expect this to do? Can someone explain this? From everything that I've shown you, you should be able to explain this.
I'll give it a try, Doc. It's asking us to retain on the rows. You start off from row 1 with an upper bound of row 3, and also on the other one, on the columns, you also retain starting from column 1 with an upper bound of column 2. So that intersection is the one that you retain.
Yeah, which is this, isn't it? Which is 4, 6, 9, 10, isn't it?
Yes.
Yeah. Did everyone get that one? Yeah.
Yes.
Yeah, I think that's it, guys. The rest is just almost a repetition of what we've been doing up there, right? But at least what was important here is the slicing and dicing, so that you clearly understand what this means, right? Yeah. Yes.
Yes, Doc.
Yeah. Yeah. Are there any questions, guys? Are there any questions? So what that means now is we've now covered Numpy arrays, right? A Numpy, numerical Python in detail, so you should be able to understand and apply Numpy. Right? And one thing you must note is Pandas is built on top of Numpy. So any of these operations are applicable to Pandas as well. Yeah. So what that means is on a Pandas data set, you should be able to slice and dice it this way, right, as well. And in that case, with Pandas, you'll be using iloc, right, index location, right? You'll be able to do that. Yes, guys?
Yes, Doc.
Yeah. So guys, that should give you enough Jana Gurumanempo. Yeah, so that should give you enough background here, Pandas and Numpy, right? So we've done quite a lot of detail, and you see why this was an important exercise when you start applying it in machine learning. Yeah. So that's it, guys. So we've done Pandas and Numpy. That's it, right? So what that simply means is we've actually prepared you for your programming exam, because this is exactly what these guys will ask. Yeah, so that's it for today, guys. So tomorrow we start a machine learning.
Okay, thank you, Doc.
Thank you, Doc.
Yeah. All right, guys. Any questions?
Thank you very much. Good night.
All right, guys. Questions? And thank you.
Thank you so much.